Find f double prime of 0 given that f of x equals x squared times sine of 1 over x squared. Okay, so pretty standard. Here's a function, find the derivative. One of the things to note is this is asking for the second derivative, which is not hard, but it's easy to overlook. And so you don't want to just immediately assume it's one derivative and then go with that, because I assume that one of the multiple choice answers will be exactly that mistake. So let's start by, I'm going to start by rewriting f of x, just because it's kind of zen for me to rewrite the problem. It gives me a moment to kind of contemplate my terrible life decisions. It's good. I will write this as x to the negative 2 instead. It's just easier to do the power rule that way. All right. So I'm going to write up the product rule, which is where we have u will be x squared, v will be sine of x to the negative 2 plus u prime v. And then instead of going through the formalities of u equals this, v equals that, take the derivatives, plug it in, I'm going to try and just go through it fluidly, mostly in my head. So it'll look like I'm skipping steps here. Yes. So start with u is x squared, and v prime will be the derivative of sine of x to the negative 2, so it'll be cosine x to the negative 2 times the derivative of x to the negative 2, which will be negative 2 times x to the negative 3. And then we'll add to this u prime, which would be 2x times sine of 1 over x squared. Okay, so this is the first derivative. Maybe I should simplify this a little bit. Maybe I can. So f prime of x would then equal x squared times negative 2 all over x cubed cosine of x to the negative 2 plus 2x times sine of 1 over x squared. Get out our blue to add some contrast for the canceling. And we're left with negative 2 over x cosine of x to the negative second plus cancel 2. No, I can't do that. That's a terrible. So in case you didn't catch it, I tried to cancel the denominator that's inside the sign. Since it's inside what we're taking a sign of, you can't do that. It is forbidden. Okay? So now we'll try and take the derivative of this as well. F prime prime of x equals, so we're again going to have, negative 2. I'm going to write this as x to the negative 1. And we're going to multiply by negative 1, get x to the negative second, cosine of x to the negative 2. So what I did was I took the derivative of this side first, multiplied by the normal of that. This is going to get challenging. Very challenging. That's okay, we'll go with it. Okay, I'm going to redo this again real quickly. Stick with red. So this will be u, this will be v. So u is negative 2x to the negative 1. And then we'll have negative sine of x to the negative second times negative 2 x to the negative 3. Is that true? Maybe true. I think that's true. Plus, ooh, wow, this is going to get long and difficult. So then this would be, we'll take the derivative of this side. So it'd be negative 2, negative 1, x to the negative 2 times cosine of x to the negative 2. Okay? And then we have to do the other side as well. So we'll do plus. This will be u, this will be v. So it'll be 2x times cosine, and this will be x to the negative 2. Cosine of x to the negative 2 times the derivative of such, which should be negative 2x to the negative 3, plus, now we'll do u prime, which will be 2 times sine of x to the negative 2. Okay? Wow, that's a lot of stuff to do. So then we want to plug in 0. So one of the red flags we have here is we have a lot of exponents to the negatives. So if we rewrite this a little bit, we have, let's see, we have a couple negatives there. So this will be, but then there's still a negative there, so we'll have a negative 4 sine of x to the negative second all over x to the negative 4 plus 2 cosine of x to the negative 2 all over 2 over x squared plus 2x cosine x to the negative 2. This becomes 4, and then there's a negative, and then there's an x cubed on the bottom, plus 2 sine of x to the negative 2. Okay. So right off the bat, you think there's a lot of x's in the denominators here. So we got x denominator. Let's do it. Ooh, green. Here, 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 and then finally over here. And I was thinking maybe when I put everything together, enough things will cancel out. But no, no. We got far too many x's in denominators. And let's see here. To get a common denominator, we'd probably do x to the 4th. So it'd be x squared multiplying just by the appropriate number of x's so they'd all be on the same, so we can combine everything. And this would be x to the 4th over x to the 4th. And so now we'd be able to combine everything. But we see, all right, so we got 2x squared. Maybe it'd cancel a little bit with that. 2 sine squared. Maybe it'd cancel a couple of those. But then we have this x to the 4th over here. So they can't really combine. Nope. There is no way this could possibly exist. And so the answer for this is going to be does not exist. So there might be a way to figure this out before we have to take all these derivatives to find out that it's not going to exist. But that's tough. So you can kind of look at this and be like, all right, this is a transcendental. So this sine of 1 over x squared, it's never, that 1 over x squared is never going to disappear. So, yep, it's difficult. So for this one, you're probably not going to find something this challenging on an AP exam. But the way you do it is just, it's pretty straightforward. Take the first derivative, use the product rule, and then I guess you have to use the chain rule for the 1 over x squared here, and then you do that again. And then you plug in 0, and you see what kind of results you get. In this case, even when you combine everything together, not enough is going to cancel out, and you're still going to be left with 1 over an x squared, which when you plug in 0, is not going to exist.